Hey everyone, my name is Jaymar Harris and I'm from Wilmington, Delaware. I'm a biology major and I'm currently a senior at Lincoln University. I'm happy to be a part of Envision's research program here at UD, and I'm excited to show you guys the project that I worked on this summer. So let's go.
The purpose of my experiment was to use 3D printed models to represent important plants' root structures in order to determine how plants interact within the soil, more specifically in a specialized region of the soil referred to as the rhizosphere. The rhizosphere is a narrow region of soil that is directly influenced by root secretions, microorganisms, bacteria, and many other organic chemical matter. In short, the rhizosphere is a living part of the soil and is usually found surrounding the plant roots. This summer, I worked with my mentor, who is also a world-renowned UD faculty member. Professor Yan Jin is an expert soil physicist with a multitude of accolades. In 2018, she received the Cannar Award for Research Excellence. In 2015, she became the first woman to be awarded the Soil Science and Soil Physics Award. And most notably, she recently received the Francis Allison Awards, which is the highest UD faculty honor. To begin my research, I completed the necessary orientation and the training credentials for the Maker Gym, UD's 3D printing, design studio, and lab.
Hi, I am Ethan Campista. I work at the University of Delaware Maker Gym. The Maker Gym is an interdisciplinary space for all majors, undergrads, graduate students, staff, faculty of the university. Anyone associated can come in here and use the space to design and create and build different things. We have 3D printers and laser cutters and a shop. Specifically with the 3D printers, it's a good way, it's a really easy tool for people to learn. In industry, 3D printing is slowly becoming more and more of a commonly used fabrication technique. So there's various manufacturing facilities that use it to actually build their own machines. So the technology's gotten good enough, the industry is using it to replace some parts that are typically metal. But our uses here are mostly just rapid prototyping. So if you have an idea for something, it's an easy way to kind of get a 3D model out.
The first step of my experiment was to create a working prototype so that we could test if it was able to perform the functions that we needed. Once we had the first plant root structure completed, we created a chamber in order to place the soil and the plant roots in. We made sure that all the dimensions were correct and that we could fit the plant roots inside. With this chamber, we were able to conduct our experiment. We used sand in our testings in order to represent the structure of soil without having the complex system that is usually found in soil. We then used our chamber and we filled it with the plant roots as well as with the sand, and then we began our test. The first test we conducted was to see the basic path of water and how it is transported through plant roots. Once we did this, we used multiple tests, including light transmission, in order to determine the water distribution throughout the soil. Further in our research, we used mucilage, which is a substance that is secreted in almost all plants and microorganisms. Mucilage is usually secreted through the plant root tips to the surrounding soil to attract bacteria and other organic substances. Once we finish testing this structure, we will move on to more realistic plant roots so we can further understand how the plant is interacting with the environment. One thing about testing soil that is very difficult is because of the variability. Oftentimes it is represented by graphs and charts and other models instead of real experiments. And modeling is surely not a substitute for experimentation, but is possibly a more rational basis for experimentation.
We're very happy to have Jaymar working on this exciting project. For the soil science community, we're always looking for the understanding of how plant roots interact with soil especially how roots modify soil physical and biological properties to maintain soil water conditions and plant functions.
The results show that the application of 3D printing in plant research are wide and will continue to grow. To attain future global food security, advancements in plant research are urgently needed. 3D printing in plant science is still in its infancy, yet pioneering studies are already showing potential of this technology to advance plant science in multiple ways. We hope that our research will help further this technology and one day be a realistic method for studying plants.